So let us look at oxidations. Obviously, oxidations are carried out using oxidizing agents. During these reactions, hydrogen atoms are lost and oxygen is gained or its content is increased. We're going to look at a number of oxidizing agents, including the Jones reagent, which you can see is sulfuric acid and chromium trioxide, the Swern reagent, which is dimethyl sulfoxide and oxalyl chloride, which should be COCl, all in parentheses twice, potassium permanganate, manganese oxide, or tetrapropylammonium peruthenate. Okay. Now, tetrapropylammonium peruthenate, you're going to see that reagent a little later on, but it looks like this. We've got a nitrogen center with 4 propyl groups on, giving us the ammonium ion, and peruthenate is RuO4-. So that is a reagent. We can also use acetic acid and sodium hypochlorite, which is what we're going to use in our experiment in the lab. The sodium hypochlorite is bleach. And then finally we've got pyridinium chlorochromate. And the pyridinium chlorochromate looks like this with the pyridine and the chloro. So there's the pyridinium and the chlorochromate. It's this. It gives us our species. So those are our oxidizing agents. Now, the reverse of what we already saw with reductions is going to be possible here. Secondary alcohols are oxidized to ketones, aldehydes are oxidized to carboxylic acids, and primary alcohols are oxidized to either aldehydes or carboxylic acids, depending on the reagent of choice. So if we take a look at our primary alcohols first, we can treat our primary alcohols with PCC to produce aldehydes. I want to emphasize that because that was what the reagent was designed for, to oxidize primary alcohols to aldehydes, which is what we see here, PCC. In order to oxidize aldehydes to carboxylic acids, we can use our potassium permanganate, we can use our manganese oxide, we can use our acetic acid and sodium hypochlorite, we can use our Jones reagent of sulfuric acid and chromium trioxide, we can use our tetrapropylammonium peruthenate, or we can use our Swern reagent, which is dimethyl sulfoxide and oxalyl chloride. Similarly, in order to oxidize a primary alcohol all the way up to a carboxylic acid, we can use again our reagents of choice. You can use any one of these. As I say, we're going to use this one in the lab, the acetic acid and bleach, sodium hypochlorite. Potassium permanganate and manganese oxide work well. Obviously, we're trying to avoid chromium reagents with the sulfuric acid. The TPAP seems to be the most efficient and most effective, a little expensive. And then finally, we've got the dimethyl sulfoxide and oxalyl chloride of the Swern reagent. So those are our primary alcohol oxidations. If we take a look at the next page, we can see that secondary alcohols are oxidized to ketones. Obviously, I know these are all familiar to you now at this point, but we can either use the potassium permanganate, we can use the manganese oxide, we can use the acetic acid and sodium hypochlorite, we can use the sulfuric acid and chromium trioxide, we can use the TPAP, we can use the dimethyl sulfoxide and oxalyl chloride. All of these are ideal reagents for oxidizing secondary alcohols to ketones. We're going to use a number of them throughout the semester, depending on the conditions and the environment. These are the ones we choose. Obviously, we're trying to avoid the chromate, but I just put it in there because everybody can remember Jones reagent. So those are our oxidations followed through with our reductions.